Okay, so we'll now be moving on with the next part of the topic, which is isomerism. So what is isomerism? Isomers are basically, we know, they are two or more compounds that have the same chemical formula but a different arrangement of atoms, or maybe different atoms altogether, but they have the same chemical formula. Okay, so this isomerism is divided into basically two types: the structural isomerism and the stereoisomerism. Okay, so what are stereoisomers? First we'll learn that. What are stereoisomers? Stereoisomers are the chemical compounds, are two or more chemical compounds which have the same chemical bonds, they have the same atoms, they have the same everything, same number of ligands, everything is same, just difference in the arrangement of those ligands in space. Spatial arrangement is different. That's how it results to stereoisomerism. Now, what is structural isomerism? Structural isomerism does not exist on the same concept. It is based on the concept that although the two compounds have different atoms altogether, have different bonds altogether, but they will be having the same chemical formula somehow. So those are called structural isomers. Now, firstly we'll study about stereoisomers. Okay, so stereoisomerism is basically two types: geometrical isomerism and optical isomerism, as we already know. But still, this thing is basically based on NCERT as far as boards is concerned, and for IIT and IT part we need to refer to the books. Those are very vast, and we need to refer to the books which like J.D. Lee for inorganic, or some other book, O.P. Tandon or something like that, for these two topics. But for boards NCERT is enough for these two topics. NCERT से ही ज़्यादातर क्वेश्चन आ जाता है रिपीट. So what is stereoisomerism? So we know that. Now what is geometrical isomerism? Geometrical isomerism, first important point in case of geometrical isomerism is that geometrical isomers, we know that these are of the one type we have studied, cis and trans, right? In which cis and trans वाले में they used to be two same compounds on the same side, तो उसको cis बोलते थे. नहीं तो different same compounds on the opposite side तो trans बोलते थे. This was trans, right? So this is basically what is geometrical isomerism. Now basic condition for geometrical isomerism: geometrical isomerism will always only occurs in heteroleptic complex, not in homoleptic complexes. Now what are heteroleptic complexes? That was explained in the first video, but still I'll say heteroleptic complexes are those in which there are more than one type of ligand. Okay, like there might be NH3 also, Cl also, there might be any other ligand also, but there cannot be the same ligand only. Okay, like only NH3 cannot be there, only Cl cannot be there. If that is the case, that compound will not show geometrical isomerism. Okay, now the second requirement is that the compound should have a square planar or an octahedral geometry. A tetrahedral complex never has or never shows geometrical isomerism. Why? The reason you will get it, and I'm telling from where, I'm saying from where will you get the reason. You need to see example number question 4 of NCERT. Okay, page number 245. It is important. You need to remember one thing, that geometrical isomerism is not shown by tetrahedral coordination compounds. Okay, now this should be in your mind ekdam clear. Now I'll be explaining from NCERT only. Okay, so geometrical isomerism, let's see from NCERT only. See, you can see here. Now this you need to know how to arrange. There is no kind of formula for it. You need to know how to arrange it, and you need to know how to write the chemical compounds in such a way that you can find out the total number of geometrical isomers. Like, say we are moving on with the NCERT example only. So important examples of this behavior are found with coordination numbers 4 and 6 in a square planar complex of formula mx2l2. What is X and L over here? X and L are unidentate ligands. Okay, and the total number of ligands in this mx2l2, you can see it is 4, x का 2 and L का 2, and the coordination number is what? Since it is written over here, it is a square planar complex, so the coordination number of mx2l2 will be 4. Now why is the coordination number and the total number of ligands same over here? Because of this reason, x and L are unidentate. So if we consider this case mx2l2, we can say that mx2l2 may what will happen? There will be 2x and there will be 2l attached to the central metal atom. Now the two ligands might be arranged in such a way कि मान लो x are on the same side and L are on the same side. Yeah, second case can be that x are on opposite side and L are on opposite side. So the first one is known as a cis form or the cis isomer, and the second one is known as a trans isomer. You need to know how to write the structure of a particular chemical compound. That's why I told you the structure of I explained you the structure of what is how square planar looks like, or how tetrahedral looks like, or how octahedral looks like, because you need to know how to write this structure. That's only the way how you can find out the geometrical isomers. Okay, like for this case mx2l2, we can take the case example of PTNH3 whole twice Cl whole twice. Okay, so you can see PT is M over here, X is NH3, and Cl is L over here. Okay, this is an example of this type. So इस case में you will see this can be written in this form. PT के लिए Cl on the same side, NH3 same side. This is cis form. Similarly this form is trans form, right? So इसमें ना there cannot be any approximation. There can be approximations, true, but those are not accurate and those are not beneficial in the long run, because you will be given such compounds जिसमें you need to know how to write these structures, because CBSE is not बेवकूफ़, okay, that they will give such structures कि तुम याद रखो and you will answer it. You need to know how to write the answer. Like इस case में I showed you how to solve. मान लो ये structure देता है, you need to know how to write this. If they have given that say PTNH3 whole twice Cl whole twice is square planar, or you have found out by some means that it is square planar, you need to know how to write these structures, and उसके बाद you will find out the total number of geometrical isomer. Now other square planar complex, say of the type MABXL over here. Now how many number of ligands over here? 4 different types of ligands. You can see this was also a heteroleptic complex with a coordination number 4. This is a heteroleptic complex. Homoleptic complex में दिखा ही नहीं सकता. So in a heteroleptic complex, in this A, B, X and L are unidentates. We can see that this, because this is a square planar complex and the coordination number is thus 4 and the number of ligands is also 4, which means that the ligands are unidentates. So how does this MABXL show 3 isomers? This shows 2 cis and 1 trans. Okay, this is a fact. Okay, you need to remember this. Like we can verify this also. Like it is written, you may attempt to draw these structures. You can try. Like say, so I'll be explaining you how this MABXL has 2 cis and 1 trans form and a total of 3 geometrical isomers. Okay, so how can we say that? For that we need to draw the structure of MABXL in whatever format we like it. This is the structure which I have assumed in the first case. So let's say that this A and B are together in the first case. Okay, now we'll change the positions of these 4 ligands. Okay, now say how many number of structures can be formed by using only these 4 ligands? MA, we can say here is B again, and L goes over here, X comes over here. So this is also a structure which can be formed जिसमें A and L are अगल बगल, B and X are अगल बगल, A and X are अगल बगल, B and L are अगल बगल. These two are different structures. Now we'll take this case. इसमें we'll draw some other structure, say A, then we'll put X over here, say, then B over here, and then L over here. This is also a different structure in which A is opposite to A is बगल में X के, B is बगल में L के. No, this is not the same structure. Okay, this and this structure was the same. we need to find the different number of structures, okay, different possible structures. So A is over here, say B is over here, say X is over here, say L is over here. Let's see कि this structure is same to someone or not. A and L are अगल बगल, B and X are अगल बगल. This is there, but this is different to this because A and B are opposite sides, and L and X are on the opposite sides. So this is a different structure. You can try drawing more structures, but you will find that you will get the same structures. Okay, मतलब resultant में same structure only you will get. In 3 का ही कोई ना कोई structure you will find out. So more structures cannot be drawn from these 4 ligands. So if we take this form, say in this form A and B are together, let's designate this as cis. अब जिसमें A and B will be together, we'll designate that as cis. तो A and B इसमें together cis, A and B इसमें together cis, A and B इसमें opposite side, this will be trans. This you could also do after drawing all the possible structures. You could also do this for L and X or L and B or for any two. Take any two and draw. Like अगर हम लोग इस cis trans के लिए ये A B के लिए हुआ, अगर कोई और 2 ligands के लिए ले लें, मान लो कि L and B के लिए भी take it, तो L and B के लिए these two on the same side to be designate this as cis again. Then इस केस में L and B are on the opposite side, so this will be trans, and इस केस में L and B are on the same side, so again cis. So again we could see that these two are cis forms and this is a trans form. For any 2 ligands, if we take them as cis and draw the resultant structures, we'll find out that 2 cis and 1 trans form will exist for MAABXL. Okay, so that is how 3 total geometrical isomers are present for this type of structure. Okay, so that is how you have to draw the structures yourself, and then you need to find out the number of cis and trans isomers. You cannot predict it beforehand by any sort of mathematical calculation. You need to draw it beforehand. And now we'll be moving on with the next type of structure, which is MX2 LL2. Okay, so this type of structure, it was also given in the NCERT, and we'll be having a look at that. Now what does this LL2 over here represent? This LL represents a didentate ligand which has 2 bonds formed with the central metal atom. This thing represents a didentate symmetrical ligand. If we would have written it like this, MX2LL-2, then it would have a unsymmetrical ligand, unsymmetrical didentate ligand. But since these two things we have written same, it is a notation for symmetrical didentate ligand. So how will this structure will exist? Basically M, X over here, X over here, and then LL2, so 2L will be there. But since L is a didentate ligand, so each L will form 2 bonds. This is how this structure will exist. Let's take the example of this type of structure. Say we have COCl2En2. Okay, En we know it is a symmetrical didentate ligand and Cl is a monodentate ligand. So if we take this structure MX2LL2, this is of that type. So CO is in the middle, Cl, Cl, En, En, each En forms 2 bonds, and this second type of structure in which these two Cl are not together, these are on the opposite sides. So these two structures are different, these two are the cis and the trans forms. Okay, so now since we learned this cis trans isomerism in case of coordination compounds, we'll learn about the second type of geometrical isomerism only, which is also there. Okay, so the second type of geometrical isomerism, the first type we know it is cis trans, the second type is FAC-MER. This type of isomerism, facial and meridional isomerism, this is present only in octahedral compounds, in suitable octahedral compounds. Now I'll explain you this via the NCERT. So let me explain you this. So this type of isomerism, geometrical isomerism, occurs in the coordination compounds with this type, Ma3B3 type, where the coordination number is 6 since it is octahedral, and there are 3 ligands of same type and 3 ligands of the different type. Okay, So say this kind of example, CONH3 whole thrice, NO3 whole thrice, this type. So इसमें what will happen, as we all know what is an octahedral structure look like, this type. अगर CO है and NH3 is 3, NO2 is 3, तो NH3 1 2 3, NO2 1 2 3. Now we'll see what does it mean by that. Okay, so let's say CO is in the middle and 3 NH3 are there. Okay, 3 NH3 are there and 3 Cl are there, 3 NO2 are there. Okay, so the first type of structure which can arise is that the NH3, okay, these two NH3 are on the same side, on the same plane. Okay, this plane is a square plane, and these two are NH3 on the same plane, and this one NH3 is pointing outwards the plane. Now there are 3 NO2, 1 NO2, 1 NO2 is down and 2 NO2 are in the plane. Now this is a square planar structure plus 2 atoms ऊपर नीचे, 2 ligands ऊपर नीचे. This octahedral structure is basically what? It is a square planar structure with 2 extra ligands attached ऊपर नीचे. So this can be one possible structure of this thing, CONH3 whole thrice, NO2 whole thrice. Okay, this can be one possible structure. In this case we can see that all these three, this NO2, this NO2 and this NO2, these three structures occupy the adjacent positions, first, second, third. Like if we have a look at this structure, these three are occupying adjacent positions. So this is called a facial isomer. Okay, this is called a facial isomer, and when the positions are around the median or are around the octahedron, like what does it mean by that? These things are very difficult to explain because they need to be explained visually, and visually I can't explain them because I'm not with you. So these things are a bit hard to explain on pen and paper. These things have to be explained by hand, so that's why I guess it's getting too difficult. But still, let's see what does it mean by the meridional isomer. Any structure other than the facial isomer will be a meridional isomer. Like why is this a meridional isomer? These two are on the same side, but there is no adjacent NO2 to it. Similarly for the case of NH2 are on the same side, but there is no adjacent NH2 to it. So this is called a meridional isomer because around the meridian there is another similar ligand, but not at the adjacent position. So this is also a fake isomer and this is a mer isomer in short form for facial and meridional. These are the two types of isomerism in coordination compounds. Geometrical isomerism. In geometrical isomerism there are two types of isomerism, this cis-trans and then facial meridional. Okay, so the next type of isomerism is optical isomerism. So what is optical isomerism? What are optical isomers? First of all, let's see that by an example. So say this is a coordination compound, CO En whole 3, and this is also CF En whole 3. So if we take this structure and this structure, like if we put a mirror in front of this structure, if we put a mirror, we see that this structure will be seen. Okay, now are these two structures superimposable on each other? Try putting this on this, you will see that these two are not superimposable. So the mirror image of this structure, the structures whose mirror images are non-superimposable on them, those two structures are known as optical isomers, and the two forms are known as dextro and levo. Depending on the direction they rotate the polarized light. Now there is a short form for it, D and L, dextro and levo form. L rotates to the left and D rotates to the right. What does it rotate? The plane polarized light. Okay, D rotates to the right, L rotates to the left. They rotate the plane of the polarized light. Now optical isomerism, we'll see that in some compounds it will be shown, like every compound might have more than one form, cis form or trans form or any type of forms they might have. Now we'll see that optical isomerism will be shown in some compounds का cis form but not in trans form. this will be seen. Okay, now like we'll see that optical isomerism is common in octahedral complexes involving didentate ligands. These are NCERT things you need to learn from the NCERT. So say in a coordination entity of this type, PTCl2 En whole 2, so this type PTCl2 En whole 2, say we are talking about only this cis form right now. If we take the cis form only and put a mirror over here, we'll see this structure is formed. Now if we try to put this on this, it is non-superimposable, so these two are mirror images. But if we try this on the transform, this thing on the transform, say what will be the transform of this Cl will come over here and this En will come over here. Visualize this En will come over here and this Cl will come over here. This En won't be there. If you're visualizing this thing and this thing will vanish, there will be one En over here and there will be one Cl over here. If you put a mirror image now, the same structure will be formed. Exactly same structure over here will be formed. Like say for this case if we see, तो इसके बगल में if we put a mirror, तो कैसा structure बनेगा? एकदम similar structure will be formed, not a different structure. So those two will be superimposable on each other. So the transform will not show optical isomerism, only the cis form could show the optical isomerism. Okay, so this is what I meant by only the cis form showing the optical isomerism. Now one more important point over here, if you find a element of symmetry like a plane of symmetry or a line of symmetry in the coordination compound ka structure, then it will definitely be optically inactive or achiral. Now one thing we learned in geometrical isomerism, that tetrahedral structures do not show geometrical isomerism. One thing important which we learn over here is that square planar complex do not show optical activity. Okay, and coordination number 4 tetrahedral complex MABCD, which did not show geometrical isomerism over there, will show optical activity over here. Now these are some things you need to keep in mind, although these can be visualized, but these are some shorthand notations which you need to keep in mind. You need to remember them at least. Like MA2B2C2 will show optical activity only in its cis form. MAA whole 2 A2 will show optical activity in its cis form. What is this AA? This is any symmetrical didentate ligand. MAB whole thrice, both cis and transform will show optical isomerism. And what is this AB over here? This is any didentate unsymmetrical ligand in which A and B are different. Okay, similarly this thing MAB whole 2 C2, so this AB is any unsymmetrical ligand, iska also cis form will only show. This thing, this यहाँ तक you have to learn. Okay, you will apply this directly in the exam whenever you find any similar kind of structure. जैसे कि कुछ भी ऐसा सेंट्रल मेटल आइटम तुमको देता है and they will give you any unsymmetrical ligand which is didentate and there are 3 such ligands in that particular coordination compound, you can directly say that both the cis and transform of it will show optical activity. Okay, that's how you have to remember these notations. You can pause the video and copy them too. Now the next kind of isomerism, as we were informed earlier, is that the pehla was the stereoisomerism and the second was structural isomerism. Now there are 4 types. Now what is structural isomerism basically? Structural isomerism is basically the one in which the compounds have different chemical bonds only. Okay, different ligands or different number of ligands or whatever it is, but it is the stereoisomers have different arrangement in space and structural isomers have different ligands only or different bonds only. Okay, so there are 4 kinds of structural isomers: linkage isomerism, coordination isomerism, ionization isomerism, and solvate or hydrate isomerism. Solvate and hydrate are the same thing. Now these are very simple. These you can learn from the NCERT also. You don't need to learn, you will just read once, you will understand. So I'll also read it once. Linkage isomerism arises in a coordination compound containing an ambidentate ligand. Now I told you what is an ambidentate ligand. An ambidentate ligand is one which has 2 sites for activity, but still it is a unidentate ligand. What is an ambidentate ligand? I explained you, like say SCN minus and NCS minus. एक केस में this nitrogen can act as the डोनर एटम जिसमें नाइट्रोजन से बॉन्ड विल बी फॉर्म्ड, एक केस में दिस सल्फर विल एक्ट एज अ डोनर एटम जिसमें सल्फर से बॉन्ड विल बी फॉर्म्ड. So SCN minus and NCS minus are ambidentate ligands. You can refer to the first video to see what is ambidentate ligand. So अगर किसी compound में अंदर में there is an ambidentate ligand, so that compound will always show a linkage isomerism. Okay, linkage isomerism मतलब बेसिकली क्या हुआ, कभी N से कनेक्ट हो गया, कभी S से कनेक्ट हो गया. जैसे अगर NO2 का बात करें तो NO2 का बात जब करेंगे तो NO2 भी का भी होता है, और O nitrito and N nitrito, these two are the forms, the ambidentate ligands. ओके, तो NO2 के केस में कभी N से कनेक्ट हो जाएगा, कभी O से. टेबल रेफ़र करो, टेबल में यू विल फाइंड आउट O nitrito and N nitrito for NO2 and ONO. These both are ambidentate ligands. ओके, सो जब भी ऐसा कुछ हो ONO and NO2 ambidentate ligand कोई भी कंपाउंड में हो तो वो लिंकेज आइसोमेरिज्म शो करेगा. Now what is coordination isomerism? कोऑर्डिनेशन आइसोमेरिज्म होता है बेसिकली ऐसा टाइप का कंपाउंड्स में जिसमें आई टोल्ड यू ना दैट थर्ड टाइप ऑफ न्यूट्रल कॉम्प्लेक्स में आई एक्सप्लेन्ड यू वन एग्जाम्पल. इन न्यूट्रल कॉम्प्लेक्स. या दिस एग्जाम्पल आई एम टॉकिंग अबाउट. In this example I told you this is also a neutral complex, but there are two coordination entities present in this case. So in this coordination entities, मान लो कि 2CN is over here, 2NH3 is over here, say 1NH3 यहाँ से यहाँ चल जाता है and 1CN comes from यहाँ to यहाँ. So a new compound will be formed and that will be a coordination isomerism of this structure. That is what is basically coordination isomerism. Say यहाँ पे भी अगर दिया हुआ है CONH3 whole thrice CrCN whole 6, तो अगर एक नया हम लोग स्ट्रक्चर देखें तो CrNH3 whole 6 COCN whole 6, ये दोनों चीज़ एक्सचेंज हो गया. NH3 चल गया पूरा 6 का 6 यहाँ, CN पूरा 6 का 6 यहाँ आ गया, तो CrNH3 whole 6 COCN whole 6. This is what is coordination isomerism is. It arises from the interchange of ligands between cationic and anionic entities of different metal ions present in a complex. It is written quite clearly. It's quite understandable. Now what is ionization isomerism? Ionization isomerism occurs तब, when does it occur? जबकि that counter anion, there is a counter anion over here, you know that? When the counter anion can act as a ligand also and as an anion also, then this type of isomerism occurs. Like मान लो कि we are taking this case CONH3 whole 5 SO4 Br. तो मान लो कि over here this SO4 is over here and this Br is over here. We have seen, we know, we can refer to the table also that this SO4 also acts as a ligand. This B as well as an anion, so it acts only. We know that SO4 2 minus is an anion, so SO4 does act as an anion, and we also know that it acts as a ligand. Now Br also, we know Br can act as an anion, that we already know, that we have seen in many examples earlier. Br तो anion है ही, and Br we have also seen that it acts as a ligand also, bromido, refer to the table. So these two things can exchange. Like this thing will displace SO4 from here to here outside. The Br will go inside, SO4 will come outside, and the new structure formed will be a ionization isomerism of the original structure. If you read the definition now, it will be quite clear. This form of isomerism arises when the counter ion in a complex salt is itself a potential ligand and can displace a ligand which can then become the counter ion. This is quite clear, I guess. Now what is solvate isomerism? Solvate isomerism is basically also known as hydrate isomerism, in which water molecules are present in the coordination compounds. वो वाटर मॉलिक्यूल्स हो सकता है बाहर चल जाए कोऑर्डिनेशन एंटिटी के या अंदर रहे. डिफरेंट नंबर ऑफ वाटर मॉलिक्यूल्स इन द कोऑर्डिनेशन एंटिटी, बट सेम नंबर ऑफ वाटर मॉलिक्यूल्स इन द एंटायर स्ट्रक्चर गिव्स अस अ सॉल्वेट आइसोमेरिज्म. पहले एग्जांपल देखते हैं. CrH2 whole 6 Cl whole 3. ओके, दिस इज़ अ स्ट्रक्चर, से दिस इज़ अ कंपाउंड. नाउ अगर हम लोग सॉल्वेट आइसोमर इसका देखें तो हो सकता है एक H2 यहाँ से निकल के बाहर चल जाए, like this CrH2 whole 5 Cl, एक Cl अंदर आ गया डिस्प्लेस होके, एक H2O बाहर चल गया, हमेशा वैसे ही होगा जैसे यहाँ पे हो रहा था, एक अंदर गया एक बाहर आया, डिस्प्लेसमेंट होगा. तो से दिस वन Cl from here goes over here and this one H2O comes out. तो this new structure will be formed CrH2O whole 5 Cl Cl2 dot H2O, Cl2 बचा यहाँ पे. Now the total number of H2O is same over here in this entire structure and this entire structure, but the number of H2O attached to it is different. So this is known as a solvate isomerism. This is similar to ionization isomerism, right? Because why it is similar to ionization isomerism? Because ionization isomerism में भी same चीज़ it was happening, displacement हो रहा था of two ligands, okay? And the same thing is happening over here also, only the difference is that here H2O or the solvate is present as a ligand. So that is what is solvate isomerism. Now in the next video we will be learning about the different bond theories, which are the valence bond theory and the crystal field theory. After that the chapter will be over.